Hello everyone, welcome to this Form 4 Additional Maths, Chapter 4, Indices, Surds and Logarithms, Clone SPM past year questions exercise. So in this video, we're going to look at 10 questions, and all these are cloned from SPM past year questions. So before we start, I will recommend you to do these questions together by pausing the video here, and you try to do this question on a piece of paper, and then after that compare with my solutions in order to benefit the most from this video. Okay, so let's start. Okay, so question number 1. Given 3 to the power of 3x equals to a, and 3 to the power of y equals to b, and 3 to the power of y plus 3x equals to 5 plus 27 to the power of x. Express a in terms of b. Okay, we want to express a in terms of b, meaning that we want to express a in terms of a as a subject in terms of b. So there's something here with the b. It might be a b squared or b and so on. So notice that given x and y here, but your final answer is a in terms of b. There is no x and y. Means in the process, we are going to eliminate x and y. We start with the equation here. So I rewrite the equation here. 3 to the power of y plus 3x equals to 5 plus 27 to the power of x. Since we know we are going to get rid of y and x, we want to, for example, substitute this with the a and a on b. Okay, so before we can substitute this with a, we need to first break this into two terms. So here we have 3 to the power of y, and then plus 3x here. It actually means, according to the formula, it means that 3 to the power of y times, okay, the plus in the power indices here, it means multiply, and with the base, the same base 3 to the power of 3x, and it is equals to 5 plus 27x. For those who are not familiar, from here to here, how do you get from here to here? You are actually using the formula, okay, a to the power of m times a to the power of n equals to a to the power of m plus n, the rule of indices. So if you're not familiar, you need to go through the laws of indices, because in this video, since you are looking at the clone past year question, SPM questions, I assume you're already familiar with all these laws of the indices and also logarithms. Now we get to from here, okay, 3 to the power of y, we know is 3 to the power of y can be replaced by b, and 3 to the power of 3x, 3 to the power of 3x is a. Okay, so we have this part done. Now we go to the left hand side here. Okay, so 27, actually, since we want to convert this to the a and b, we need to have 27 convert it to the base of 3. Here the base is 27, so we're going to change this to base 3. So 27 is 3 to the power of 3. Don't forget to put the brackets here, and hence AB here becomes 5 plus. So this part here, 3 to the power of 3x. 3 to the power of 3x is actually a. So this becomes a. Now we want to express a in terms of b, means I'm going to move the a to the left hand side, so that I have a, b minus a equals to 5. Then I factorize the a. I left b minus 1. Okay, and then I move this to the right. I get a equals to 5 over b minus 1. So the answer is a in terms of b. This is the final answer. Now we go to question number 2. Given 4 to the power of p plus 4 to the power of p, which is equals to 4 to the power of q, express q in terms of p. Okay, so again, notice that the p and the q is the indices. So we need to do something here. We try to simplify this. So for this part, actually, you notice that these two terms is the same. So we can simplify this. 4p plus 4p is actually 2 4p. If you don't understand why, you can treat this as a. You see, if a plus a, you get 2a. Okay, so 4 to the power of p plus 4 to the power of p is actually 2 4p to the power of p, okay, which is 4 to the power of q. And then we can further simplify this by moving this to the other side. I get this 4 to the power of q over 4 to the power of p, and then this here, yeah, using the law of indices, a to the power of n divided by a to the power of n equals to a to the power of n minus n. Yeah, so the division here actually is this. The over here represents division. So you get 4 to the power of q minus p. But then since we want to express q in terms of p, yeah, we need to form an equation with q and p. Okay, so since the base is different here, okay, we can change the base 4 to base 2 by letting 4 equals to 2 to the power of 2. Now 2 to the power of 2 is 4, right? So P, Q and P here, and then I multiply this to both here, both of the Q and P, I get 2 to the power of 2Q minus 2P. And since the base is the same, base 2, so by comparison of the indices, okay, indices here, this is 1, 2 to the power of 1 is 2, okay, so by comparison of the indices, we can take 1 equals to this because they have the same base, okay, so 1 equals 2q minus 2p, and then I think should not be a problem. I just continue here. Since we want to express q in terms of p, I move the 2 here, I get this. Okay, so I rewrite this, q equals to 1 minus 2p over 2. That is the answer. We'll look at question 3 and 4. So given log base p of 2 equals to x and log base q of 5 equals to y, express log base 2 of 20p squared in terms of x and y. Again, we want to get rid of the p here. We only want x and y. So express log base 2 of 20p squared equals to, we try to break this part down so that it only consists of the 2 and 5 and p. But the first thing you need to check here is the base. Yeah, you see this has base 2, log base 2. Here the base is p. So the first thing, you always check the base, and we try to convert it so that they have the same base. So now log base 2 here, we want to use the law of a logarithm, changing the base. So it becomes log base p, log base p. So this 20 p to the power of 2 or squared, and the 2 we'll write here. So now we have changed log of base 2 to base p. So after that, we can break this part into numbers which consist of 2 and 5. Okay, so the easiest way is 20 is actually 4 times 5. Okay, so p squared. And 4 is actually 2 squared. Okay, so 4 is actually 2 squared. And for this part here, log base p of 2 here is actually x, so we can just substitute that with x. Now using the law of logarithm, we can take this part here and we rewrite this as this. And don't forget the 2 here, you can use the law to bring it to the front here, so I just write the 2 at the front, plus log base p of 5 plus log base p of p squared. Again, the squared here, the power, the indices here, we can put it in the front, so I just move it here over x. So log base p of 2 is actually x, so it becomes 2x. Log base p of 5, log base p of 5 is y. And then log base p of p is always equals to 1, okay, because log base of the same values here is always equals to 1. So we have 2 here, 2 times 1 is 2 over x. So this is your answer. Okay, we express this in terms of x and y. Now we look at question number 4. Given log base a of 2 equals to p, express log base 4 of 8a squared in terms of p. So it's quite similar to question number 3. So the first thing we do here, we have to convert this log base 4 here. Then we try to change this to log base a. Okay, so we get log base a, log base a. This one is 8a squared. Here is 4. Okay, so again, why we want to convert this to log base a, because given here log base a, so we change from log base 4 to log base a. Next, since we are given log base a of 2 is p, so we try to make this number, the 8, we try to change to 2, a number with base 2, and 4 same as well, and this is number with base 2. So now the 8 is actually 2 to the power of 3, and the 3 here I can bring it, nope, it's this, and it becomes plus log base a of a squared. Okay, so this 8a squared, we write it as in this form, over log base a of 4. 4 is actually 2 to the power of 2, and now we just take all these indices in the front using the law of logarithms. So I have 3 log base a of 2 plus 2 log base a of a, which is equals to 1, and 2 log base a of 2. Log base a of 2 is given as p here, so 3p plus 2, log base a of a is 1 over 2p. So you want to further simplify from here, you get 3 over 2 plus 1 over p. Given log base 3 of y equals to 4 over log base xy of 9, express x in terms of y. Okay, so since you see this given equation here, one of the log has base 3, one of the log has base xy. Yeah, so the first thing we do, we try to convert one of this so that both have the same base. So let's try to convert this, the log with the base xy, to log of base 3, log base 3. Okay, so we use the law of indices. Okay, so we only change the denominator. So base 3, the 9 right here, and then the log base 3 here, we have this xy here, xy. So in order to, we can rewrite this and simplify this. Just if you have problems with this, a divided by b over c, or a over b over c, is actually equals to a divided by b over c, a multiply a equals to a multiply c over b equals to ac over b. So here it becomes 4 times log base 3 of xy over log base 3 of 9. Okay, so base the 9 here, I can rewrite this as base 3 of 2. So base rewrite this as 3 to the power of 2, and the 2 I can bring it to front. I write here. So now I have, okay, so now here the log base 3 of 3 is actually 1. So 2 times 1 is 1, and this 2 and this 2 can simplify. I get 2 log base 3 of xy. And I move the 2 here, becomes the indices of xy. So it becomes xy to the power of 2. So be careful here, the squared here applies to both x and y, not just y only. So now since we have both sides, the left hand side and right hand side, with the same base, so by comparison, y here equals to this. Okay, so y equals to x squared y squared. But since we want the answer in x in terms of y, Okay, so let me rewrite this. I think it's better I write as xy squared here. Since we want to express x in terms of y, okay, I write this up here. I move the square to the right hand side. I get the left hand side, I get square root of y equals to xy. Usually when we write square root here, we add plus or minus, but since y is this value here, okay, this value must always be positive. Okay, remember, if you have log with any numbers here, this a value here must always be a positive number. It cannot be a negative number. That's why I didn't put a negative here. It must be a positive value. And then I move the y here to the left. I get square root of y over y. So square root of y divided by y. So we can further simplify this part because y is actually square root of y times square root of y. Then I can cancel off to get x. Okay, I can cancel off this. So finally, x equals to 1 over square root of y. This is the final answer. So I erase everything here so that I have space to write the solution for question number 6. Given this, express in terms of x. Okay, so now this one, okay, this one is just a error here. Okay, so log base a of q to the power of -2. Actually, by using the law of indices, I can move the -2 in front. Okay, so since log base a of q is x, so the answer is -2x. That's it. 1 mark for this. And now we go to this part here. First, you check the base. It's different. Now, since it's different, we need to change the base first. Okay, so we can write this as log base a, because we want it to be this, so that we can substitute it with x. Yeah, and this one right here, and this one I write here. So the square root of a is actually a to the power of 1 over 2. And by using the law, okay, I can bring the 1 over 2 to the front. I'll do it in the next step. So for the numerator part, I can rewrite this as log base a of q plus the multiplication rule, log base a of a to the power of 4. And the 4, I can write it in front here. For the denominator, I have this. So log base a of q is given as x. Log base a of a here is 1. Log base a of a is 1, so it's 1 over 2. So if you want to further simplify this, here you have 2x plus 8. This is the final answer. Okay, there are a few ways of doing question 7 here, and I'm just going to show you one of the way, which is by taking 3 to the power of p equals to another unknown, okay, another constant, like for example a. Okay, so since this equals to this equals to this, so if 3 to the power of p equals to a, hence 7 to the power of q also equals to a, because they are equal. Okay, so we let this happens. So p equals to log base 3 of a. Okay, again, this is the basic thing that you need to know. Okay, so p, the power here, equals to log base 3 of a. Same applies here. Q equals to log base 7 of a. This is the basic. So now we have p and q in the form of log numbers. And the last one here, we have 21 to the power of r. We also let this become equals to a. Okay, so we also let 21 to the power of r equals to a, because this equals to a, hence this equals to a, this also equals to a. So r equals to log 21 base 21 of a. And now what will happen if I change the base of this 21 here into base of 3? Okay, so we try. So let base 3, so a will be here, 21 will be here. Log base 3 of a is already p, so we already know that this will be p. Okay, so I write the p here. But what happens to the values or the denominators? Okay, so we can further write this as 3 to the power of 3 times 7, which is equals to log base 3 of 3 plus log base 3 of 7 using the multiplication rule. Then log base 3 of 3 is 1. Log base 3 of 7, we can change this again, either by using, because we want to involve P and Q here, which must have an A. Okay, so I change this, I convert this to log base A. So log base A of 3. Okay, so this part here now becomes this, using the laws of logarithm again, by changing the base from base 3 to base A. Now this is not done yet because so R here, we continue from here. So you can see that this is log base A of 7, but here is log base 7 of 8. So we need to further change this part. So there's one rule here, like for example, log base A of B. Okay, this is actually equals to, if we let this becomes, we convert this so that it has a base B. Okay, so what will happen? So if base B, the B is here, the A is here, so log base B of B is 1. Okay, so you can see that if you want to switch the position of A and B, if you want to switch the position of A and B becomes B and A, it becomes 1 over log base B of A. So by using this law, here we get 1 over log base 7 of A for this part, for the numerator part. Okay, numerator part. And then for the denominator part here, becomes 1 over log base 3 of A. Why we are doing this? Because we know that log base 7 of A is Q and log base 3 of A is P. So now we can substitute here this one with 1 over Q, and this part here it becomes 1 over P. And then we get rid of all the log numbers. So now log is gone. We only have P, Q, and R. We can express R in terms of P and Q by further simplifying this part. So now, so this part here, okay, 1 over Q divided by 1 over P is actually 1 over Q times P over 1. So you get P over Q. So if you want to further simplify this, okay, actually this one you get Q over Q plus P over Q. Now the 1 here you change to Q over Q. So you get Q plus P over Q. And then it becomes PQ Q plus P. Okay, how? Because P divide, this one here means divide by Q plus P over Q, actually means P times Q over Q plus P. So P times Q, you get PQ lah, and divide by Q plus P. So this is the final answer. Okay, so here I show you another way of doing question number 7, which is easier. So again, first we need to let 3 to the power of P equals to A. And again, because if we let this equals to A, means 7 to the power of Q also equals to A, 21 to the power of R also equals to A. Okay, so if we let this equals to A, so now P equals to log base 3 of A. Same applies to this again, so I just write this down. Okay, then we have a 21 to the power of R equals to A. So R equals to log base 21 of A. So since all of these have a different Okay, here there's a mistake here. This is supposed to be 7. So since all of these have different base, okay, so in order to change them, convert them so that they all have the same base A here, we can use the A here. Okay, we can write P equals to 1 over log base A of 3. Okay, again, because this is using the changing the law of logarithms, where when we change the base, okay, like for example, if we have log base A of B, okay, we can change it to log base C, a new base, okay, where the B here is written here and the A is written here. How about if we want to change log base A of B, so that both now becomes log B, okay, hence the B is still here, the A is here, and log B of B is actually equals to 1. So you can see that if you want to switch the position of these two values here, okay, it becomes 1 over log base B of A. Okay, so this if you want to switch the position between 3 and A, it becomes 1 over log base A of 3. Same applies here, 1 over log base A of 7. And here we can also write this as 1 over log base A of 21. So now all of these have the same base now. Same base. And then so log base A of 21 actually equals to 3 times 7. So I can rewrite this as log base A of 3 plus log base A of 7. And since, okay, I write here, and since log base A of 3 is, log base A of 3 is here, this one, and this equals to log base A of 3, we can switch position between the P and this. We get log base A of 3 equals to 1 over P. Okay, so this now becomes 1 over P. Same here, if I switch this to log base A of 7 equals to 1 over Q. So log base A of 7 equals to 1 over Q. And now I get rid of all the logs, I just have to simplify this. Okay, so in order to add the fractions with different denominators, we only have to multiply. Now multiply this by Q, multiply this by P. So I get P, Q, nope, I get P plus Q over PQ, and then if I divide this, I get R equals to PQ over P plus Q. And we go to question number 8. Given this equals to 2, express A in terms of B. So this is the indices type of question. So first thing, we need to make sure all indices have the same base so that we can simplify it. So the easiest way one is to change it to 2. Okay, so we have 2 to the power of 4 for 16, and we have 2 to the power of 5, 6. Check. 2 to the power of 6, yes. 1 minus b. Now they all have the same base, I just have to proceed with this. Okay, so 4 times a times 2, I get 2, and then 4a plus 8. And here we have, this is 6 times 1, 6 times b. Okay, so I get 6 minus 6b equals to 2. By using the law of indices, since they have the same base and there's a division here, I get 4a plus 8 minus 6 minus 6b. Okay, this is 6b equals to 2. So even though there's no power here, actually it means power 1. So by comparison, I write at the left hand side here, 4a plus 8 minus 6 plus, okay, because this one applies to both terms, plus 6b equals to 1. Okay, by comparison of the indices only, because they have the same base, so we can use a comparison. So we just simplify this. Okay, 4a plus 2 plus 6b equals to 1. 4a equals to 1 minus 2 minus 6b. So I get negative 1 minus 6b, I get this over 4. Question number 9. Solve this. Okay, so first, again, we check the base. They have different base, so it's better we change this so that you have the same base of k. So by using the law, we have this over this. So the 3k here is here, the square root of k, or k to the power of 1 over 2 is the same as square root of k. It's here. So the 1 over 2 again, I can bring it to the front. And then 1 over 2 times this one is 1. So actually it becomes, okay, I rewrite this. 1 over 2 times 1 is 1 over 2. Okay, so when you divide by 1 over 2, so when you divide by 1 over 2, actually it means, okay, like for example this one, divide by 1 over 2, it actually means times 2. We switch to, so it actually becomes 2 here. And don't forget the 2 here, we can bring the 2 up here so that it becomes the power of 3k. So now they have the same base. We can combine these two terms by using the law of logarithms. Becomes 144 over, okay, because it's a minus, so it's divide 3k squared equals to 2. And then to get rid of the log here, we just move the k. You get 144 over 3k squared. 3k squared, it becomes 9k squared lah. Okay, k to the power of 2. And then I just move the k squared to the other side. Get 144 divided by 9 equals to k to the power of 4. 4 divided by 9 is 16. K to the power of 4 equals to 16. So k equals to the fourth root of 16. Okay, the fourth root of 16, it can be positive or negative, but since k is the base of the log, k must be a positive value. Okay, k must be a positive value, so that's why I didn't put the plus minus sign here, because it must be a positive value, so the answer is 2. It must be a positive 2. Question number 10. Express this in the form of k times 2 to the power of p minus 1. Okay, so we start with this first. Plus 2 to the power of p plus 1 minus 2 to the power of p minus 1. So we try to write this in this form where 2 to the power of p times 2 to the power of 2. Okay, so this one actually equals to this. Okay, and this part here equals to 2 to the power of p times 2 to the power of 1. Okay, because of this is 1, so I don't have to write the 1 here. And this one here, we get 2 to the power of p times 2 to the power of negative 1. Then you can factorize 2p, 2 to the power of p. Okay, and what is left inside the bracket here is this, this, and this. Okay, 2 to the power of 2 is 4 plus 2 minus 2 to the power of negative 1, which is 1 over 2. Then you calculate. Okay, 4 plus 2 is 6. 6 minus, this is actually 1 over 2. So 6 minus 1 over 2, you get 5. 1 over 2, which is 5.5 lah. 5.5, or it is 11 over 2. Either one. But if you look at the question, we want it to be 2 to the power of p minus 1. So if we exchange the position of 11 and this, because it's multiplication, okay, we can write 11 here, 2 to the power of p here. Okay, so this now becomes 2p minus 1, okay, because it's divided by 2. Hence, we have done the first part of question 10. Express the expression here in the form of here, in this form where 11 is the k. Now we look at the equation. It says hence, solve the equation. Hence here implies that you need to use the information from the first part to help you to do the second part. So I think actually it's quite obvious. We know that we need to change this. We need to replace this by using this, because this can be expressed in this form. Hence, this we substitute with the 11 to the power of p minus 1. And just copy the rest here. 2 to the power of p to the power of 2, yeah? Okay. So now we further simplify this because it's multiplication, the 11 and 11 here cancel off. The 8 here, I think it's better if we change it to number with base 2. So 2 to the power of 3. Okay, times 2 to the power of p minus 1 equals to 2 to the power of p to the power of 2. In this part, we can combine this. It becomes 2 to the power of 3 plus p minus 1 because of the laws of indices. And since now they have the same base, so by comparison of the indices, we get that this equals to this. Okay, because they have the same base. So 3 plus p minus 1 equals to p squared. So we only have one variables left. This is a quadratic equation because of a power 2. We solve the quadratic equation. Yeah, so here we have 2 plus p equals to p squared. I move everything here to the other side. I get p squared minus p minus 2 equals to 0. Factorize it. Plus 1 minus 2. So I get p plus 1 equals to 0, or p minus 2 equals to 0. So p equals to negative 1, or p equals to 2. For this case, p can be the value of negative 1 or 2. So this is the end of this video. I'll see you in the next video.